purpose of this video is to review some of the basic ideas behind acids, bases, and pH. Let's start by just reminding ourselves what the difference between a strong and a weak acid is. As I'm sure you're aware, strong acids fully dissociate. That means that they entirely break apart to form protons and the ion, or the conjugate base, of the acid. Weak acids, conversely, only partially dissociate. So we've got an equilibrium. The acid breaks apart, we form our protons and the conjugate base of the acid. But all three species, the weak acid, the ions, all of them are present. Now, when you look at an exam question, one of the key things is, how do you know whether something is a strong acid or a weak acid? And the key thing to look out for is a Ka value. A Ka value is telling you that we are dealing with an equilibrium. So therefore, we must be dealing with a weak acid. Alternatively, we may end up with a pKa value. All of these things indicate that the acid is a weak acid. If there's no Ka, if there's no pKa, we're probably talking about a strong acid that you're not familiar with. A novel one that the exam board are going to ask you to do some kind of calculation with. The calculations for strong acids are usually more straightforward. Weak acids, because we've got Ka and possibly even pKa involved, are going to be slightly more complex. But that's the key thing. Ka, pKa tell you that you are dealing with a weak acid. Okay, let's just look at strong acids briefly. What is it that we need to be able to do in terms of calculation work for a strong acid? Well, as you remember, there is an equation. pH is equal to minus log base 10 of H plus ion concentration. Now, in your calculator, if you've just got a log button, if you have a look at the top on a scientific calculator, this should be a log button. And on lots of scientific calculators, that is automatically going to be a log 10 button. On more complex calculators, it might have log with a little blank box, and you actually have to tell the calculator that you want to do the calculation in log 10. If not, the button's just going to be a log 10 and you don't need to worry about that. Now, this calculation, this equation, is clearly enabling you to calculate the pH of a strong acid if you know the concentration of hydrogen ions. So the question is, how do you know what the concentration of hydrogen ions is? Well, in the question, invariably, there will be the concentration of the acid. So let's imagine we've got a concentration of acid at 0.11 mole per decimeter cubed. Now, because we're dealing with a strong acid, that means that that acid entirely dissociates. So if we start with 0.11 moles of strong acid, we're going to end up with 0.11 moles per decimeter cubed of H plus ions. So the value in the question for a monoprotic acid is going to tell us what the concentration of the H plus ions is. Now, if we had an acid like sulfuric acid, clearly, in this case, if we knew the concentration of the acid, the concentration of the hydrogen ions, because we form 2 protons for each mole of acid that we have, we're going to end up with double the concentration. That's just something to bear in mind. That does come up. So just be aware of how many protons you make for each mole of acid, which breaks apart. So once you know your concentration of the acid, you can work out the concentration of the protons, and then all you have to do is stick that into the equation. Okay, as we've said, weak acids partially dissociate. So let's take a weak acid. Let's think about ethanoic acid. there's going to be an equilibrium between the ethanoate ion and protons and the undissociated acid. Now, it's partially dissociating, so in the question we're either going to have a Ka or a pKa value. That's telling us about this equilibrium. And if we need to think about an expression for Ka, Ka is the acid dissociation constant, we're going to have the concentration of the products divided by the concentration of the reactants. It's like a special case of Kc, isn't it? We're dealing with acids here. So once you know your Ka value and you start to know all of the different values for all the different concentrations, you can calculate ultimately concentration of hydrogen ions. And the moment you know the concentration of hydrogen ions, you can use the formula we've just been looking at for strong acids to work out pH. So let's imagine we are given a value for Ka. We are given a concentration of ethanoic acid. What do we do to work out the concentration of hydrogen ions? Well, clearly, the key thing that we need to take into account is that when we look at this equilibrium, we have to make the assumption that although we have got some degree of dissociation, the position of equilibrium lies very, very, very much to the left-hand side. So we can make an assumption that even when we have got some partial dissociation, the concentration of the weak acid remains unchanged. So if they tell you you've got a concentration of 0.10 moles per decimeter cubed of the weak acid, even though there has been some degree of dissociation, we're still going to use that value in the equation. So if we're given Ka, we're given the concentration of the weak acid, how do we work out the concentration of hydrogen ions? Well, we have to clearly make the assumption that the concentration of this and this will be the same. So what we can do is say that Ka would be equal to H plus concentration squared, because these two values will be the same. And that's going to be divided by the concentration of the weak acid, which is given in the question. Now, historically, this could have been worth anything up to 4 marks on paper 1, but in recent years it has featured as a 1-mark multiple choice question. So the examiners are imagining or expecting you to remember this formula. How do you work out the concentration of hydrogen ions from this equation? Well, it's going to be equal to the square root of Ka times by the concentration of the weak acid. So whatever the concentration of the weak acid is, you're going to multiply it by the Ka value, square root that gives you H plus, and as we know, pH equals minus log to the base 10 of hydrogen ion concentration. Just stepping back to strong acids now. We've worked out how to calculate pH if we're given the concentration of hydrogen ions. How do we work out the concentration of hydrogen ions if we're given the pH? Well, we've got to do the inverse function of the pH equation, which is going to be 10 to the power of minus pH. So here I've got my calculator. Let's imagine that the pH of our solution is 3. So what would H plus concentration be? Well, if I find my log button on my calculator around here, in order to calculate hydrogen concentration, all I have to do is we're looking for this function here, 10 to the power of. So we're going to have shift to get to that function. That function is nearly always above the log button. And I'm just going to put in minus 3, minus pH. Get that, simplify it. And if the pH is 3, the concentration would be, there we go, just as the calculator showed us. Again, relatively simple calculation, but one which does come up in Year 13 exam papers. Moving back onto weak acids. We did say that we know that an acid is a weak acid if we get a Ka or a pKa value. And we've just looked at how to use the Ka value to calculate the concentration of H plus ions in solution. What happens if you're given a pKa value? What's the relationship between pKa and Ka? Well, pKa equals minus log of Ka. So if you're ever asked to calculate pKa, given Ka, similar process to what you did to calculate pH. If you need to know Ka, so let's imagine in a question about a weak acid, they're going to ask you to calculate the pH of the weak acid. You're going to need to calculate the concentration of the H plus ions. To be able to do that, you need a Ka value. So if they give you a pKa value, that is just going to be 10 to the power of minus pKa. So it should be relatively easy to calculate the Ka value and then use that in the way that we were just doing to calculate the H plus ion concentration, and then go on to use that to calculate pH. The next thing we need to look at, and the final thing we're going to look at in this video, is how to calculate the pH of a strong base. Now, whenever we're calculating pH, we need to know what the concentration of hydrogen ions is. And it may seem a little bit counterintuitive to think about bases, alkalis, containing H plus ions. Well, they do. It's just that the concentrations are exceptionally low. Now, the key thing that we need to know about here is this constant, the ionic product of water. And the ionic product of water has this value. If I remember correctly, that is on the data sheet. And the ionic product of water also equals the concentration of hydrogen ions multiplied by the concentration of hydroxide ions in solution. So what that is saying is the product of hydrogen ions times by hydroxide ions will equal 1 multiplied by 10 to the minus 14. Now, in an exam question, what you will be told is information about hydroxide ions, either the concentration of the alkali. So if they give you a concentration of the alkali, they give you a concentration of sodium hydroxide, for example, the concentration of hydroxide ions will be the same as the concentration of sodium hydroxide. So if you know your hydroxide ion concentration, and you know that value, it's possible to rearrange the equation to calculate H plus. And the moment you know H plus ion concentration, you can use pH equals minus log to the base 10 of hydrogen ion concentration to work out the pH. Now, how could the examiners make this more complex? Rather than giving you the concentration of hydroxide ions, they may give you the mass of alkali. They could give you a volume of water. and from the mass of the alkali and the MR of the alkali, you can calculate the number of moles, and from the number of moles and the volume, you can calculate concentration. So it's a way of them testing things that you did earlier in the course to do with concentration equals moles divided by volume, Mr. Moles with a mass on his head type calculations, and then bring that into the context of pH calculations. So that's something that they could do to make it slightly more complicated. Again, what they could do to make it even more complex still is they could tell you the pH of the alkali. And from the pH of the alkali, you can work out the concentration of hydrogen ions. If you know the concentration of hydrogen ions and you know the ionic product of water, you can then work out the concentration of hydroxide ions. And hopefully you can see that we may at this point be working backwards, so that if we know the concentration of hydroxide, we could then work out, if we were given a volume of solution or we were given a mass of alkali, we could potentially work out the MR of the alkali. Or if we were given the MR of the alkali, we could work out the mass of the alkali. All of these are the kinds of calculations that the examiners could set. So that's really just a very, very basic reintroduction to the idea of calculating pHs of strong acids, weak acids, strong alkalis.